Hello all, this is Muhammad Aftab, and in this video we'll be doing INE based topology configurations, looking at this massive topology, right? Basically this is the logical topology what you see on the screen. If you have not purchased INE volume 1 workbook, please go for it one. All the labs in their workbooks are designed on this logical topology. It is worth spending money on this particular workbook. So let's get started. Basically I'm using a web IOU to do this particular topology. You can Google it and you'll find one. So basically if you see this particular topology, right, it will not give you a complete understanding how the physical connectivity is done. We will be drawing the diagram based on this particular physical topology, because I mean this is the logical topology, right? So if we connect to switch 1, right, and with the help of show CDP neighbor, this particular output, if you're not familiar with this, it's pretty easy. So we are running this particular command on switch 1, right, show CDP neighbor. Now it says that it's local interface, so let's concentrate on Ethernet 4/0. This switch Ethernet interface, that is 4/0, is connected to switch 4, right? So if I had to draw, let's say if this was switch 1, and so as per the output, this particular switch 1 is connected to switch 4 on its local interface 4/0, and the remote port ID of that particular switch 4 is E2/0. Are you getting this? Right, I'm very bad at diagram, so I just created this topology for you. Using GNS3. Yep, right. So, and from this particular output we see that we are connected, our 3 links are connected to switch 4, right, which is 4/0. So 4/1 is connected to 2/1, 4/0 is connected to 2/0, and 4/2 is connected to 2/2. So it's like slot 4 port 0 is connected to slot 2 port 0, and vice versa. So 1 and 2 and 1 and 2, right? So if you look at this particular diagram, these 3 links are connected with this particular 3 links. I'll give you the link for this particular topology, but understanding this is pretty quite important, because based on this links, we, if we are good with layer 2, working on layer 3 becomes easier, right? Similarly, as per my this thing, 3 links from 2/0 is connected to 2/2 or switch 2, and if you consider this diagram, 2/0 till 2/0, right? Similarly for switch 3, I have 303132 connected to 2021 and 22. So switch 1 connects to switch 3 via Ethernet 3/0, 3/1, 3/2, and the remote ports are 2/0, 2/1 and 2/2, right? Which means I have almost 9 links, 1 2 3 6 and 9 links connected to this thing. So it's quite clear that these links should be trunking, right? This and this. If you look at the output on switch 2, I have another, say from switch 2, 3 links 202122 connecting to 202122 on remote switch 1. So if I execute this command on switch 2, I see 20 is connected to 22. Similarly, my Ethernet link 303132 connects me to switch 3. As you can see in this diagram, these 3 links connects me to this 3 links, right? And for switch 4, I'm using my Ethernet interface 4, right? And I have R2, R4 and R6 connected. R2, R4 and R6 connected on switch 2, as well as the backbone router BB2. These are my local interfaces and the remote interface that is connected to BB2. And on switch 3, I can just validate the same. Three links to switch 4 using my Ethernet interface 4, and the remote ports are also 4041 and 42. So switch 3 force this interfaces. Switch 2, from 3 I'm connected to switch 2 using my Ethernet port 3, and the remote ports are also 3 or slot 3. And for switch 1, 202122 connects to 3031 and 32. 2021 and 22 connects to 3031 and 32. I also have a backbone router BB3 and router 5 on its port 1/1. I have on port 1/1 router 5 and Ethernet 00 connects to BB3, right? So this is the physical diagram what we can make up. Now if we look at the logical topology, right, we see that these 3 ports are in VLAN 146, right? So my port that is on router 1 E00, router 1 E00 connects to E0/1, which means on switch 1 port E0/1 show run interface E0/1 would be part of VLAN 146. I've already done this configuration. So R1 0/0 connects to E0/1. So looking at this particular diagram, I see that R1 0/0 is connected to VLAN 146. In the logical diagram you see them, they are connected with a straight line. But R4 0/1 is, oh I'm sorry, this needs to be deleted. R4 0/1 connects to E1/0 on switch 4. So if R1 and R4 had to communicate, the packet will come on switch 1. Then based on the underlying spanning tree topology, the packet would be sent either on the trunk link among this one. If it was a ether channel, these 3 ports were put into an ether channel. Either it would be, say, port channel 1, 2 and 3. Based on the underlying spanning tree topology, the packet would be routed from switch 1, because switch 1 is also doing routing, and hence it would be routed either on this or this link, right? So the concept of VLAN comes into place. So once we put this port, that is E0/1 into port VLAN 146, E1/0 on 146, which also signifies that R1 will be learning, switch 1 would be learning the MAC address of R1 on port E0/1, right? If I say show MAC address table on a particular port, show MAC address, say VLAN 146, right? Now I can see that this is learnt on port 0/1, wherein the MAC address of R40/1, which was basically learnt on ports switch 4, that was local to this, right? So E1/0 R4 Ethernet port was learnt on this particular, the MAC address was learnt on port E1/0, right? Which means this MAC address on switch 1 was learnt on Ethernet port 4/0. So you can see that because in this topology switch 1 is the root, right? So because it is root, switch 4 has a direct path using one of the 3 links to reach the root, that is switch 1. As a result, the MAC address which was connected or learnt on this port would learnt on switch 1 on port 4/0. Similarly, you can follow for all the other routers based on this topology. I'll just walk you through this. So router 146 are in VLAN 146, as you can see this here, right? So basically INE is using a subnet. The major subnet is 150.x dot again x.x, right? Now basically the first one or the second octet here, you will get to see their rack number. If you're provided with rack 20, so you will get 150.20. something dot something, right? Now in the third octet, if the connectivity is between R1, R4 and R6, that is 1, 4 and 6, so this would be 146, right? And the dot x at the end would be the router number. So if it is router 1, it is R1, so 150.20.146.1, this would be 155, sorry, 150 is for loopback, my apologies. 155 is a interfaces IP address. So 155.20.146.4 and .6 for router 6. Similarly, for between R1 and R3, it would be 13, 13.1, 13.3. So the major subnet would be 155.20.13. R1 it is 1, and if it is R3 it is R3, right? Between 4 and 5 it is 45, the router numbers, right? Between 6 and switch 1 is considered as router number 7. So between 6 and 7, 79. Switch 1 and switch 3 would be 79. My apologies, my bad, I said 6 and 7, 67, right? So it is 67 here subnet, here it is a 79 subnet. Between 5 and 8 it is 58, right? So 155.120.58.5 here and 8 here, right? Between switch 2 and switch 4 it is 108. Between router 3 and router 2, it's between 2 and 3, so the subnet is 23. So 155.20.23.3 for R3 and 2 for R2. So once you have the complete topology up and running and configured, you can ping 155.1.146.1, 4 and 6. Thank you for watching.